we now come to the third and the last presentation in this session. And I would like to ask Nikola Tosic to introduce the next speaker.
Thank you, Professor Dan. So it is my pleasure to announce the presentation of the paper titled The Applicability of Superabsorbent Polymer as a Protective Carrier in the Bio-Based Self-Healing Concrete. This is a presentation that will be given by Hana Schreiberova, and it is coming from the work within her PhD thesis of self-healing bio-based concrete that is being done at the Czech Technical University in Prague and the Faculty of Civil Engineering. So Hana, the floor is yours with 15 minutes of presentation and questions afterwards.
So hello, my name is Hana Schreiberova, and I would like to present you our paper which focuses on the applicability of the superabsorbent polymer in the bio-based self-healing concrete. Firstly, what is the bio-based self-healing concrete? It's a cementitious material which uses the so-called biocalcification process to enhance the natural crack sealing potential of concrete. Therefore, it limits the negative impacts of cracks to the material's durability. The biocalcification process is simply said production of calcium carbonate by certain bacteria. The process generally requires some kind of biological agent consisted of bacteria, spores, and nutrients, water, and in majority cases, oxygen. In theory, the bio-based self-healing concrete is rather simple. The self-healing agent, which is the bacteria and nutrients, is added into the concrete mix during the mixing process. The bacteria stays there inactive in the form of spores. And when a crack is occurred, the water penetrating through the crack together with the nutrients activates the bacteria metabolism, and it starts to produce calcium carbonate, which finally seals the cracks. However, several issues have been detected in the past research. The bacteria, although it is in its resistant form, it is not able to survive the crystalline pressures during the cement hardening. And further, a sufficient water supply must be ensured, which could be problematic, especially in the case of vertical structures. To solve these drawbacks, a number of studies proposed various protective methods of bacteria. In our paper, we focus on the application of the superabsorbent polymers, which only few studies have investigated so far. The possible functionality of the SAP in concrete is multi-layered. Firstly, the SAPs are usually proposed as a means of internal curing. Thus, it may enhance the natural autogenous self-healing capacity of concrete itself. Further, the polymer could serve as a protection of the bacteria and also ensure the needed water supply, as it is able to absorb liquid up to 100 times its own weight. In our paper, to determine the applicability of SAP in the bio-based self-healing concrete, 4 cementitious composite mixes were prepared, as you can see. All of them contain nutritional additives needed for the biocalcification process. That's the calcium lactate and yeast extract. And their composition and dosage were based on the studies described elsewhere in the literature. The series BAC and SAP BAC further contained bacteria, specifically Bacteria bacillus pseudothermus, and the series control SAP and SAP BAC were further enriched with 0.5% of SAP by weight of cement. In the case of SAP addition, extra mixing water was added to the mix in order to make up for the liquid absorbed by the polymer, so the past workability remained similar to the control series. Firstly, the prepared paste were casted into steel molds with reinforcement, as you can see in the figure 2. And after 24 hours, the specimens were demolded and cured in the climate chamber for 28 days. Then, at the end of the curing period, the samples were subjected to control cracking. So the reinforced beams were slowly loaded through a 3-point bending test. So a crack would form in the middle of the span of the specimens without complete loss of the sample's integrity, as you can see in the figure 3. Then the cracked samples were then placed into water-filled plastic containers and left at room temperature for 28 days to heal. Before and after the healing period, the cracks were monitored through high-resolution photographic imaging and scanning optical microscopy. In this figure, figure 4, you can see the images of the chosen cracks before and after the healing process. And it is apparent in all of the cases some level of crack sealing, that's the white crystalline precipitates, took place. In these pictures, the yellow arrows mark the maximum crack width that was healed in the 28 days healing period. This value was ultimately chosen for the comparison between the prepared mixes. In this graph, the average maximum healed crack width are compared. In the control sample, that's Superabsorbent, the average maximum healed crack width reached 0.18 millimeters. In the BAC samples where bacteria was incorporated, the average width increased to 0.23 millimeters. And in samples where only SAP was added, the average initial crack width reached up to 0.26 millimeters. Finally, in the samples SAP-BAC containing both the bacteria and the SAP, the precipitates could be observed in cracks with the average initial width up to 0.28 millimeters. So it reached the highest values. So in conclusion, in this study, we detected several interesting points. Firstly, the proposed combination and dosage of the bacteria and nutrients proved to be suitable, as the crack sealing was enhanced by their addition compared to the control series. Further, the SAP itself seems to have a profound positive impact on the crack healing. In our case, it reached even better results than the bacteria addition alone. The combination of the bacteria and SAP in our study led to the most effective crack sealing. However, the protective mechanism will need to be further investigated, as the contribution of the bacteria seem to be similar to the samples without the SAP protection. And for me, that's all. Thank you for your attention.
Thank you for the presentation. So then we open the floor for questions from the audience, please. So maybe while we wait for the first questions, I would like to ask, because maybe I missed or didn't understood, were mechanical properties tested of the concretes to know if they are of different strengths, seeing that if I understood well, there were very different crack widths in the different types of concretes. So is it different tensile strength or any properties that were tested?
No, in this study, we did a preliminary test with the similar mixes, but unfortunately not in this one. However, the SAP decreases the tensile strength a little bit of the material, but it's not that significant.
Okay, Professor Dan has a question.
Yeah, thank you for this nice presentation. I have a question related to the effect of self-healing, you said. How did you verify, or how have you verified that there is a self-healing of cracks? Have you done any penetration tests, for example?
No, unfortunately, we did not. Was like sort of a preliminary test of the SAP application. Further, in this study, we measured change of dynamic modulus through, sorry, I forgot the English name for it, but we didn't do it in the test here. Yeah.
Maybe a short question related to the first one, and then Avi comes with his question. And
yes, of course.
Do you think, of course, you have combined the bacteria with the SAPs?
Yes.
Do you believe, or do you think that this healing effect is caused by the bacteria, or maybe by a blocking due to the expansive effect of the swelling of the SAP?
I think it's both. It could be visually seen that the swelling of the SAP is blocking the cracks, especially in the microscopic scanning pictures. But the newly formed crystalline white precipitates, they were newly formed. So I think it's the outcome of the maybe delayed calcification, or yeah. So I think it's both.
Okay, thank you very much.
Thank you, Professor Dan and Hana. So we go now to questions from the audience. We have several. The first one we have from Avran Sigier. I'm sorry if I'm mispronouncing your name. Who is asking, can you say anything about the mechanical properties, for example, tensile strength, of the healed concrete? Or do you plan to check this aspect?
Yeah, in the further study, we are checking, like I said, the recovery of the dynamic modulus. However, it's the application of the bio-based self-healing concrete doesn't really target the restoration of the mechanical properties. It's more about the durability. So the creation of the layer which covers the cracks is more important than the restoration of the mechanical properties itself. I don't know if it means, if I say
yes, no, if I understood, so it is not the primary focus of your, your research. So it is, I think, in the similar spirit is a question by Professor Torrenti that he's thanking you for the presentation and asking about the resilience of the healing if a mechanical stress is again applied. I suppose this is the same answer, that it is not direct focus, no?
Yes.
Okay, from Professor Sandrine Mansuta, we have a question. Is there a reason why you are using a cement type 1, 42.5? Did you compare with limestone cement type 2?
It's the cement type 1 we applied just because it's the most common one in Czech Republic. So we wanted to do replicable study. We tested with the cement type 2, and the self-healing itself, the autogenous self-healing, was decreased. However, the mechanical properties dropped significantly, and it was very hard to work with the samples, as they tend to lose their just the crack completely, so the cracks wouldn't form, so we could see the self-healing. We just destroyed the samples. So then we used cement tape one further.
Okay, thank you. Professor Lukilis has a question. I think that the found results depend on cement type and his interaction with bacteria. Have you tested other cements? This is again in the similar line. Do you have anything else to add?
Yes, of course, the cement type has a great impact. I don't think it has a impact from the perspective that it somehow reacts with the bacteria itself. I think the bacteria doesn't really care for the type of cement, but the natural self-healing capacity of cement is closely linked to the cement type itself. So yeah.
Okay. And we have another question by Professor Torrenti. So we discussed, you said that the mechanical properties are not in the focus, they're changed, but if there is a cyclic loading, will the sealing effect be preserved?
Yeah, it's the topic of the further research. There are studies which focus on the mechanical properties of the newly formed precipitates, for example, through nanoindentation. And yeah, the results are, they varied from, I don't know, it's just complicated, and I think we will focus it on further research. But now we did not focus on the mechanical properties of the newly formed material itself.
Okay, another comment to this effect from Avram Dansigier. Please note that the same actions causing the crack development, for example, temperature effects, will continue to affect the healed structure. So mechanical properties may not be decoupled from durability considerations.
Mm.
So I think we are hearing a lot of arguments in this favor that is good to consider also the healed properties.
Yeah, sure.
In this slide, can you then a bit elaborate in this further research? Are you planning any upscaling of the tests, or what is the plan?
Now we are doing a study which involves the testing of the samples in various conditions, such as low temperatures and after the freeze-thaw cycles, as the bacteria metabolism is closely linked to its condition, especially to the temperature. And so we are focusing on that. Then, as I say, the changes of dynamic modulus, we want to see if the mechanical properties can be restored up to a certain point, which now it seems it does. But as it has been said, we should further focus on the multiple cracking, so to see if the self-healing is effectuous for more cycles than one.
Okay, thank you. There is a question from Jean Lozé. Is there a limit to the lifetime of the bacteria? If so, could the self-healing occur later on with the same efficiency?
It's very hard to say, because this type of bacteria, they are able to live up to hundreds and hundreds of years in hostile environments, such as in stones and volcanoes and stuff. But it's very difficult to say after the mixing process in the cement or in the during the crystalline process, during the hardening of the cement. It's very difficult to say. And testing of the viability of bacteria after their incorporation into the mix is very difficult, because you need complete sterile environment, which generally in cement labs it's very difficult to sustain. So it depends, but I think we will further focus on some kind of longer period test, which would involve, I don't know, 1 year, 2 year samples, which we would crack, but it's in the future.
Okay, thank you. Another question from Professor Lukili. Have you noticed a big difference in rheology of materials? The absorption rate of the superabsorbent polymers is modified by the presence of bacteria?
Now it seems that the presence of bacteria doesn't have an impact on the SAP swelling properties. The SAP properties are closely linked to the ionic composition of the liquid which they are in. So that's the main reason why the swelling is different in different mixes, and it's closely related more than the bacteria to the nutrition applied, because we are applying, as it was somewhere here, the calcium lactate and yeast extract. So yeah, more these nutrients than the bacteria itself.
Thank you. And there is another question by Professor Dehn. If I understand correctly, external water is needed for initiating the healing process. Is therefore this technique applicable to certain climate regions only?
Yes, that's the problem we are focusing on now, because firstly the water is needed, which, as I said, it could be problematic in case of vertical structures or in climate regions where there is no rain. So that's why we think that application of SAP could be complementary, as the water retention of the SAP could provide needed moisture, for example, in the periods when there is no rain, no moisture. But yeah, it's problem, and also the temperature. It could be very problematic, because the ideal temperature for the bacteria, it's somewhere between 25 to 30 degrees Celsius. So, for example, in our region, Czech Republic, this temperature is quite high, and it's not reachable all year round.
See, thank you. Professor Mansuter has another question on what is the impact of the SAP on the setting time?
Yeah, the workability or the flowability of the paste changes rather quickly, as the SAP is uptaking more and more liquid as the mixing process goes. By the addition of the extra distillate water, we reached a similar flowability of the paste, but the setting time is prolonged quite significantly. We did test only the flowability right after the mixing process, but further we should focus on the setting time as well, as visually we could see there is a very pronounced change. And
how can you comment on how much time are we talking about? How much more time does it take? Any measure?
Yeah, we didn't test it, so it was just we actually couldn't demold the samples the next day, because it was still too weak. So I don't know, but exactly. Yeah, but I think it's like 8-9 hours delayed from the control saviors.
Okay. Professor Dehn is asking a question about the scaling factor. Are the gained results on these small samples transferable to real scale?
we did not experiment with other samples than the small ones, but in literature there are described several experiments with real application in walls, in dams, or samples at larger scales. And it seems that with the larger scales, the self-healing is decreased quite significantly. It could be for various reasons. For example, the placement of the self-healing agent, the bacteria and nutrients, it's dispersed in the whole volume of the structure, although we need it just in the upper layer where the crack is formed. So it could be the results of the not sufficient mixing. It's difficult to say, but it's problematic. It seems problematic.
Is there anything on the effect of presence of reinforcement on affecting the performance?
Theoretically, there should not be any problem with that, because we are just adding the bacteria and the nutrition. I think the reinforcement, it's not problematic here. It could be difficult in case, for example, high strength concrete, where the crack would, I don't know, it wouldn't hit the possible carriers of the self-healing agent. But yeah, I think reinforcement, it's not the problem here.
Okay. From Professor Lucchili, I think the first is a comment and then a question that the absorption of SAP increases in distilled water.
Yes.
Yes. And the question is, have you measured the absorption of SAP in the nutritional solutions?
Yes, I did, and it was decreased significantly. So we added the additional extra mixing water in regard of this information.
Can you clarify a bit more? Professor Lucchili is asking why.
Why is it lower? Oh, wait, yeah. It's lower because of the ionic composition of the final solution. As we are the distilled water, it doesn't contain any ionic solution, as we are adding additional the calcium lactic and yeast extract. It increases the ionic percentage in the solution, and thus the swelling of the SAP is significantly decreased.
Okay, I will say a final comment from Professor Den that there is a large European innovative training network project called Smart Inks, and you should follow the newsletter. I will type in the comments the name of the project. So it is dealing with the topic and it's probably interesting for you to follow. So if there are no further questions, I think we are close to time, and thank you all. This has generated a very, very lively discussion. And yes, thank you, Hana, and I will turn over to Professor Dane for closing the session. Thank you.
Thank you.
Yes, thank you very much to all presenters. Thank you very much to all of you in the digital room, in the digital space following this presentation. And it was a pleasure. And of course, I would like to thank also my co-chairs in the session, Nikola Tosic and Ahmet Lucchili, for chairing the session. It was a real pleasure. The presentations were very well prepared. So thank you very much to all of them. And of course, we wish you a very successful further PhD symposium. And with this, I would like to close the session. But before we close the session, I would also like to thank our maître de cérémonie, Farid, for taking all this responsibility to switch the presentations. So thank you very much for this help. Thank you very much, and keep and stay healthy. Thank you very much.